you want to kick us off, Emily?
Happy to. Everyone, if you haven't already or you missed it, sign into the document. I'm gonna post this again for those who joined a bit later. Would you mind, I guess you already kicked off the live stream. So we're good on that front. Up next, do we have any new faces? Anyone who hasn't been at the working group before and would like to introduce themselves to the group today?
I guess I can start. So hey everyone, I'm Ben. I'm working at Bloomberg together with Sambav and Aidan, though in a different team. I'm working around DevX, and yeah, we're interested in build packs for some of our Kubernetes deployments.
Welcome.
Thanks.
Guess I can go next. Hey everyone, I'm Suraj. I'm just joined Ben's team really, and I'm working on the build pack side of thing in our team as well. So yeah, that's me.
Awesome. It's great to have you guys here.
We also have Dan here.
Yeah, hi there. I thought I'd just be shadowing and not disrupt much, but I'm Dan. I'm also in the same team as Ben and Suraj. I started recently and I work with them on the build pack stories.
Well, welcome to all of our new faces. Moving on to our next standing item. Do we have any release planning updates? Maybe Natalie, you can kick us off with the status of lifecycle.
I think we're just waiting on a couple of things to be finalized in the platform API before we can wrap up all the items for the next release. So stay tuned.
And on the platform side, do we have any releases coming up? Oh, Javier.
Yeah, no, not that I'm aware of. Pack was released not so long ago, so I think we're good there.
All right, thanks everybody. Moving on to our topics for today. We've put support Docker files on the agenda. Am I correct, Natalie, that it was your desire to talk about this one specifically today, or was that Stephen?
I did. I was hoping to maybe just get some clarity on a couple of things, but if we want to start with something else that might be more interesting to the wider group, I'm happy with that too.
Or faster? Do you want me to just move this to the end then?
Yeah.
So we'll come back to that one. Let's talk about the run image SBOM. Hopefully this will be a shorter topic. I feel like maybe the point of this is to corner Stephen here to talk about our desire to switch to providing the run image SBOM to the exporter and sort of like kicking responsibility for managing it to the platform for now, instead of baking it into the image. I know you had mentioned some hesitation about that, so maybe Stephen, you could sort of describe to us why you want to bake it into the image, and we can talk about it.
It would be it'd be great if the way we're consuming the run image as an artifact could be as a sign, as a artifact with a signed SBOM in a common format, right? I don't think I have a preference for it being baked into the image itself in the way that we bake it into the app image so that we can reconstruct it, but I wouldn't be opposed to that either. So it'd be easier to, kind of pull that SBOM the way we, construct the SBOM for the app image. What's the what's the issue with consuming the run image with the SBOM attached to it in some way?
Go ahead, Sam.
So I think the plan was you could still attach the SBOM to the run image. It's just that we as a project won't own the specification or attaching SBOMs to base images. The platform, let's say Pack, wants to support SBOMs attached in cosine format. It could read that off from the run image and make it available to the exporter. Or like if it wants to inject other things in the SBOM, it could do that as well. So like it removes the requirement for us as a project to maintain the specification for also tagging SBOMs for the base images.
So if I'm running, say, Tecton, and I do a build just using the lifecycle, and that uses a run image from Docker Hub, and that run image has cosine has a cosine attestation for the SBOM in it. How do I make sure that the app image I get has the base image? Are you saying we could still add it to the lifecycle, but it wouldn't be spec'd, or would you require the platform to somehow implement pulling the run image SBOM and feeding it into the lifecycle in the case of creator even?
Yeah, the latter. So in case of Tecton, they could, like, there's a prepare step anyway that does a bunch of things. It would just run cosine SBOM download with the base images and put them in the directory on the volume, the common volume that's mounted across everything, and the lifecycle would read that. It's also useful for other things. Let's say the platform wants to inject other bits to the SBOM, like not just based off the run image. Let's say it wants to take the run image's input and create a SBOM dynamically in case it doesn't find one. It would also do that. That was the idea.
Is part of the motivation that we're trying not to pick a winner yet for the attachment style?
I recorded some of the reasons we brought up when we had this discussion before. Number one being it changes the tooling that you use to create your SBOM, right? You meet your run image. You can't just use a Docker file anymore. You now need to use this tooling that then creates the image, and then modifies it because the image itself is referencing a digest of the layer, right? Or the diff ID. Number two, like people modify these images with Docker files to make new versions of them. And then once you've baked the run image in, it's fallen out of date. And we don't know whether, like at build time, we don't know whether people didn't know that it was there and now we're using the out of date thing, or if it's, being updated or is still valid. And then number three, we don't want to pick a winner. Like we sort of had to in the layer method, the layer BOM, because it's important that we restore it. So we had to specify something so that we could have the rebuild story, but that's not true for the run image. So we could leave the flexibility to, integrate with these different solutions until a winner emerges. Platforms can make that choice.
So those seem like reasons not to it, or most of those seem like reasons not to encode the SBOM in the same format that we have it in the app image, right? Like inside of the image itself, but they don't, or most of those wouldn't apply to a SBOM that's external to the image because it would be referencing a digest that would like change if you used a Docker file, or right. So are there any disadvantages to just, I guess the only disadvantage to respecting a like cosine attestation of an SBOM would be that we'd have to pick that format, right? That's what we're going to use. And so we'd just like to skip specking that. I think I'm okay with that.
And I think we can pick things like that to integrate with in Pack. It's just about whether we're building it into the like stack specification and into the lifecycle interface.
Yeah, it's really just, I want to make sure that lifecycle remains an independently usable, useful tool, if that makes sense. And so, because I think we encourage platforms to adopt Pack and thus Docker, right? If we don't keep creator, kind of relevant. Are we putting other things in the prepare, like, do we need to integrate more prepare phase into the creator? Would that kind of solve the problem?
I think like it sort of ties back to the conversation we had last working group, right? Like this is again something that's very specific to the platform. The build pack will never see the input bomb attached to the build image or the run image. So like we can include it as a common binary that we provided as a project. It doesn't need to be a part of the lifecycle.
I mean, I think it's not about whether it's like, I just care about the user interface for the lifecycle, right? Like there's a really simple use case here, which is like you have a run image on the registry, you're building an app image, you want to end up with a valid SBOM in the end. And then, if to implement this, a platform has to execute a bunch of steps outside of the lifecycle just because we said, well, technically, we don't want to spec this part yet, right? I think it's okay if we're saying we don't want to spec how a platform needs to consume that, but maybe that means that for the single phase lifecycle run, right, where it users expect to be able to just invoke one thing to do a build pack build in the container, we integrate more of those external binaries if they're external, or extra lifecycle binaries if they're in the lifecycle and prepare phase, however we do that organization, then I think I would be okay with this until there's a winner for the format.
There were two things. One, even apart from the winner, if you're consuming a run image of the game, for example, you won't have the SBOM. What if, as a platform, you want to make sure that regardless of whether the input image had an SBOM or not, you want to produce an additional SBOM? How do you do that? And the other thing was like, regardless of create or not, I thought prepare was going to run as a separate phase or a separate container entirely.
Yeah, I think it's that flexibility that the platforms need is what we're trying to satisfy. And that's why I don't think, at least in the immediate future, running it as one or it being part of the life cycle phases is like in scope.
Maybe we should pull creator out of life cycle.
Maybe. I think the lifecycle serves a very particular purpose, which is providing this compatibility layer between platforms and build packs. So like, we don't want the platforms to have to deal with the complexity of orchestrating the build packs themselves, but we have this well-defined build pack API, so we need the build packs to be orchestrated in a specific way. And the lifecycle like bridges that gap. I think for things that are just platform features, we can provide a great user interface, but it doesn't have to be in the life cycle, And then people can opt in and out of it, and we don't have to, it can just be a well-documented API and be like, I'd love to plug in this component before or after my build. It doesn't have to be part of this platform API.
I think it doesn't bother me as much if lifecycle goes outside of scope of what's in the spec, right? It's like it's a tool people are going to use. There's behavior that we're saying, these are part of the contract, right? There's behavior that, isn't defined as part of that contract. But I don't have a very strong opinion about it. I think if we want to, provide if we want lifecycle to be very, not to err away from clean user interface and more towards, or to err away from useful user interface and more towards implementation of the spec as it's written in a as generic a way as possible, then I think we should pull stuff out of lifecycle in order to build that cleaner interface for platforms that need that like Tecton, right? And so I'd say again, like it's fine if we don't, especially because I agree that we can't really pick a winner so far for the attachment. So it's fine with me if we don't, in the life cycle itself, or in at least in the spec, right, consume the run image SBOM. But for a platform like Tecton, the default should be if there's a SBOM attached to the run image, we should carry that through. And so maybe that just means we should pull creator out.
I don't have much of an opinion there, but I would kind of reinforce that it's not so much about the clean interface, it's more about the flexibility, right? Like platforms would want the flexibility to be able to inject additional SBOMs and sort of stuff. And I think it makes a lot of sense. That being said, I do have a concern. I know someone at some point, there was a proposal that the run image might be dynamically selected through the from Docker file syntax. That I think would make it difficult for the platforms to preemptively be able to provide an SBOM. Right, so is there a solution for that, or have we considered that?
I think, I don't think it would be too difficult because you already need a separate container in order to build the run image, unless we're going to implement something where we replace the entire current container with the Docker file build and then swap back. I think at some point you're going to have to execute another lifecycle binary, and that would give the platform an opportunity to hook, grabbing whatever selected run image came out of the Docker file build and using that. Right.
Okay, so we have an injection point.
I think so. Yeah, I think we should. I mean, sorry. It was just feedback. I think that gives us an injection point. The only case is unless we're planning a creator flow where in the middle of the build, it uses Conoco to replace the entire current container with the run image container, does a build, and then swaps the whole container back to the builder. If we were to do that, then it wouldn't, work as well. But I think even in the Tecton case, we plan to have a separate parallel task run, but I could be wrong. I don't know what the status of the implementation is.
Definitely not at that point. We did have it sort of up on the chalkboard as like maybe one day, but it's not something that we are looking at right now.
So I think we can defer that until we get to that point then.
So I guess back to this RFC. Are we okay going forward with the platform sort of owning it, providing the SBOM?
I think so, but I'd like to see kind of a commitment to making sure the lifecycle still it's still reasonable to use the creator to do a build that ends up with a signed SBOM in the end.
Signed SBOM or just an SBOM?
That's a good question.
We haven't introduced signatures anyway right now. So
I think maybe we should, we've talked in the past about how the implementation team might be poorly named, right? There's many things that are implementations. I'd like to think about sort of like platform author tooling, like what tooling do we provide so that people can construct platforms, right? And I think the life cycle is just one piece of that, and it's a special piece. It's the piece that every platform must use, because otherwise we cannot make guarantees that the build packs work the way that they were intended to. And then we should think about sort of like what interfaces we want to provide to platforms to build on top of, without always coupling that to what do we want to add to the lifecycle interface, because I think these two things could be different.
Yeah, I'm in favor of the idea of platform tooling. I think that may already fall onto the platform team sort of idea. I think the fact that Pack is the primary focus of the platform team is maybe the disservice.
Sort of the way I've started thinking about this in my mind is like this: we got the build pack author tooling. The implementation team right now is actually like platform author tooling, like it's producing something for platforms to use. And then what we're calling the platform team right now is really about, like, if we reframed everything in terms of the consumers of it, it's more like directly end user facing tooling, including platforms.
I mean, if you take the current logic of back team owning the utility build packs, you can sort of see the platform team owning the author tooling as well as the implementation platform, so that they offer platform so that they can dog food whatever they've created.
Yeah, that's true. I mean, that's getting into the weeds, but I feel like we put everything we want to give as a tool to platforms into the lifecycle right now. I just want to like give us new ways to reframe that so that we don't have to do that when it doesn't make sense.
I think we've talked about creating separate tools in other repos when it makes sense for the platform to consume them, like, you know, in an out of band context, right? When we don't want to version them with the platform API, when a platform might want to use those tools separately. And the versioning doesn't matter. I worry that if we scope lifecycle down to, you know, this just implements the spec as it is and really avoid adding any other tools, there are tools that, you know, we're going to have this other contract that we create between the lifecycle and this other tool, you know, and we already have this problem where we have a lot of different APIs. It's kind of difficult to manage them. And so in some cases,
well, I don't think we should have a contract between the lifecycle and the other tools, which is why I was sort of pushing back on Sam's when we were talking about the cosine RFC, right? Like, should it take in report TOML or something like that? But I feel like if you leave you don't need to create new interfaces as long as the platform is mediating.
But I think if you moved creator out to a different tool, those things would be heavily intrinsically, like you'd have a contract of even just in the Go API, you'd end up.
Well, I'm not suggesting moving creator out to a different tool.
I think that's what we end up needing to do if we want to create a good interface for platforms to be able to do image builds, right? Like you know, I don't think you should have to use Pack if you're in a CI platform that provides containers and doesn't provide Docker, right? There's no reason you couldn't just execute a binary and do a build pack build, right? In the context of, you know, wherever you are, right? Like it seems important to be able to preserve that, you know, being able to build with that Docker functionality without requiring somebody to deeply understand the build pack API and, you know, implement all these kind of things outside of the life cycle because they, you know, technically fall outside of some very generic spec, right? Like I think we're working against.
I'm not asking people to, like the tying it to Docker is not what I was proposing. I was just saying that it's a separate binary that you can run before. It's just a binary you have to execute. It doesn't require the presence of Docker. We can improve the interface for that. Like if the creator had some hook saying that if it finds binaries in certain places, it will invoke them before it launches detect and after it completes export.
But there's no reason the creator couldn't be a single statically linked Go binary that you can execute in any context and do a build pack build, right? Other than, you know, this like architectural decision, right? That creator has to stay pure, right? Or something like that.
I think these architectural decisions matter because it's about like what can change together and what can change independently, right? I also don't think that like you know, from the beginning, we talked about like many platforms could just use lifecycle in these Docker contexts. I feel like that really hasn't panned out like that. All of those, the types of platforms you're talking about have all chosen to use. I feel like there's two prototypes of platforms. It's either like choosing to use Pack or kind of re-implementing Pack, like the Spring Boot plugin, or there's the run phases in, you know, order in Kubernetes, like Kpack and Tecton.
Can I interject that we're at halftime? Just calling that out here. And I feel like we have, wow, great discussion and important. I feel like we have moved away from the original RFC discussion, even though it is related with tooling and other stuff.
I think I'm hesitant to say we should proceed with kind of continuing to move stuff out of the lifecycle implementation until we have a better solution for platform authors who want to, or sorry, for, people who want to do a build pack build without Docker, right? I feel like we're moving too much out of that implementation. We can call time, but you know, we should figure this out eventually.
Yeah, like maybe we should, I feel like we should come back to this sooner than next week, because I'd love to get the SBOM stuff to a place where we can really stand behind it as having everything you need in there. So we need a solution for the run image to do that. And therefore, it seems like we need to get through the philosophical conversation to get back to the practical one, right?
Yeah, and then we have 3 other RFCs that kind of rely on the same sort of philosophical question.
But moving on here, next up on the agenda is export to OCI.
Yeah, that's mine. Let me share my screen. Well, I just want to answer 2 things. So we can try to use the time. So first of all, here is the, I update my previous RFC with a that I did for the publish operation, and I changed that one to, based on what we discussed on the last office hour, to just add into the exporter the capability to save the exported image when the daemon flag is enabled to disk using the OCI layout format, and then update the report toml with some metadata that these new tools can use to complete some operation and verify that everything is fine. More or less, that's the idea, and that's what I tried to put here. You can take a look on the draft RFC if you want, but I want to focus on 2 things. The first one is yesterday on the sync meeting, Jesse suggests this thing. I expressed the feature just to be used only when the daemon flag is enabled, because I mean that's actually the use case that it's having troubles, right, with the annotations and the cosine stuff. But Jesse pointed out that why we can just enable the export into OCI format, no matter you're using the daemon or not. And so I just wanted to ask that to everybody, if everybody see any reason to why we can't just export the image if the user wants to the disk, right? I believe the only reason we put it with the daemon was because the daemon was the one that was causing some troubles with losing the metadata if we sign the image or we add annotations. But anyone see any case for someone that published the image to a registry and actually wants also the image exported on disk that can prevent us to enable that?
I think I can see a use case where you don't have the daemon, you're not publishing to the registry, but you want the output image on disk. That's like the only use case where I can think where it might make sense to have an additional export flag.
Do we currently support multiple registry locations?
Support multiple repos in the same registry, but not multiple registries.
And that restriction is because it's just performance based, or it's like because you really want to run image that's coming from one registry or the other registry, and so it's always going to be slow for one of them. Is that right?
But it's a user decision, right? If you enable the flag, you can't. You must be sure that it's going to be slow. So it's up to you.
Yeah, I'm just thinking about it. If we already have an interface where you can export to multiple registries, right? Does it make sense to view this as like an extension of, because you're talking about adding, just so I understood, you're talking about exporting to disk as a thing in addition to a registry or the daemon, right? And like, should we make it so that these are all additive things, right? You can specify any number of targets, right? And because we're already doing multiple registry locations, it is a little, it's not like it's multiple repos within, one registry, right? So that's not exactly, distinct targets. That's maybe a hint that, an interface for doing that makes sense, but I'm not very strongly opinionated. All right, I don't have a use case for being able to do both disk and registry at the same time. So
I do think maybe in the past we've been too restrictive on people in order to prevent them from doing really slow things. Like, I guess if people want to do really slow things, they should be able to, but there is a communication challenge there where I think then people will just assume, I think the reason we did it in the first place is people assume the system is slow and it's not obvious to them, like how to re-architect to make it fast. And sort of by building those restrictions in, then people are getting it to work the way they would like it to by default. So there's like a trade-off between, sometimes people have a good reason for wanting to do this and they don't care that it's slow versus, the opposite of that.
Maybe we should support any number of targets specified in any order for any location, and then use a URI or something to denote the daemon versus the OCI on disk. There's some tools that have conventions for that already, right? We could use, and then if you do multiple registries, we do a warning and say, oh, this is going to be slow no matter what, because the run image has to come from one place or another.
We do say things like, we'll never like re-download a launch layer from the registry. Like we would not be doing that anymore, right? Like if you're using a run image in a registry and one of your export targets is the disk, you're going to download a lot of layers. And that's fine. I feel like we just like literally write that down and say it in a lot of places.
There is a question of like, because we pull from the target image in the end, or is this just about the exporter and not about the
this is
that's
just
the exporter.
Yeah, this is just for the exporter.
So the platform has to decide if the platform has multiple images, it cares about multiple locations. It has to decide first where it's going to pull metadata from, where it's going to like pull cache from, and so it doesn't really matter at the level of the exporter. None of these are special. Yeah. Okay.
I like the idea of using the OCI scheme, URI scheme to control this and being able to do multiple. That'd be great, because you could, I could see that easily feeding into what we have now. When we remove like daemon support, we can just append Pack could just pass in an OCI layout URI scheme to accomplish this.
Okay. That's good insight for my first stuff. The other one I want to get some feedback is okay, so this one is based on updating the report toml with some information that then can be used for these other tools. So what I did a few minutes ago was adding this section here. It's just a basic idea I had, but I would like to hear some feedback about it. So the idea is, if we enable the flag to export to disk, then what we were discussing was, okay, so the idea for this information is to be the input for another tool to do something with the image exporting in OCI. And then when that image can push that to a registry, then it can verify the consistency, right, of that image versus the one that I pushed. So what I did was, okay, so we need the digest, right? So that's what we were talking, and the digest must be calculated based on the compressed layers, which is the expected one to be used when we pushed. The manifest size, okay, I saw that in the previous TOML file. And then what we discussed yesterday was, okay, Javier pointed out that, for example, if someone uses a different library than the GCR library or use some other things, maybe the calculation could be different, right? So we said, okay, we need to specify that this information is, if you use our tool, you use this library and everything. That's what we are trying to suggest, right? So actually, I tried to put these things, right? So we are using this library to create this image in this format and this compression algorithm and everything else that can be useful. So more or less, this is the draft idea of, and I put it on a different section because I don't know, maybe we export that thing on a different format and it's not OCI, then we can add something else there.
So I'm trying to understand those last four fields. I don't, if the goal is like to be able to reproduce the digest in the first field, I don't think it's enough information because it's not, it's not just the compression algorithm that's used, it's like the compression level and even specific, different implementations of gzip can, it's like,
okay,
there's not a very strong guarantee that, unless you're using the same code, right? And you have the library, or you are saying this code right here, but there's not a very strong guarantee that that's going to always produce the same digest. What's
okay.
the goal behind that reproducibility? Maybe I missed that point.
The goal for this information, if I understood correctly, if I understood correctly was, okay, so we are trying to use this one when you are using the daemon, right? So we create this new image in the format in the disk, so you can use the other tool to complete the push of that thing and have everything you wanted there. So when that publish stuff actually complete the operation and push the image to the registry, we want to have something to be sure that what we put in the daemon, it's the same thing we are pushing to the registry, right?
Why? So when you do a build and you're targeting the registry, or sorry, when you do a build and you're targeting the daemon, right? Why not just store all that information, like everything you need, including all the bits, right, outside of the daemon also, so that you don't have to reach back into the daemon and pull it out and then rerun these operations on it? Like, why not just cache everything outside, and then when you push, you're just uploading stuff in the cache?
I think the original idea was like we can do two things, right? We can put the layers in compressed format on disk, or we can leave them uncompressed, just sort of what Lifecycle already does, and reuse it for the launch cache. So we were trying to satisfy two things. One was like Lifecycle already sort of kind of puts the output in OCI-ish format for the launch cache, but it's uncompressed. It's not compressed. Could we reuse those bits for efficiency, and then our final pack publish or publish whatever operation can just verify that the inputs are at the things that it sort of took as input matched what the lifecycle was expecting to publish out if it would have published it out to the registry. Like the goal, at least from when I was imagining it, was not reproducibility, but just correctness. Like if you just need the digest and the manifest size to make sure that what you're pushing out is the exact same thing as what the life cycle expected. The others,
that came yesterday, right? It's there any guarantee that if I implement the publish stuff with a different library and a different language, I will have the same digest?
You will not have the same, and if it's not the same, you just fail. But if you want to have a compliant publish, which like it's unlikely that there are multiple different versions of publish, you need to be somewhat in lockstep with what the lifecycle does, right?
So the idea for putting this information here was to make clear to someone that it's implementing the published, okay, we are telling you, you have to use this.
But what if they can't? Like, what if it's like an implementation of publish in like Python or Rust or something, and like that library language and URL information is not useful?
Yeah, but that's why we said, okay, if we are putting this here to do that validation, then we just wanted to be clear that we are putting this here because we are expecting you to use these libraries and this method to complete the operation and do the validation. Otherwise, it's up to you. But that's why that's what more or less we discussed yesterday, right? Why we need to do this, put this digest and stuff for something that it didn't happen. But it's like predicting the future, right? If you push this thing, you are expecting to have this digest. So we're saying, okay, if you are predicting the future, then at least tell everybody that you are predicting the future based on this library and this method and this way to do it. Otherwise, you are not going to get the same result.
I mean, you could potentially get the same result without using GGCR, right? You just have to verify that the digest and manifest size are the same.
Yeah, when I try to repro this, it's not really GGCR, it's Go, right?
Yeah.
It has to be in Go, the GZIP part. But yeah, like there was no other way I can get the same digest using various libraries or languages.
So I want to back up a little bit from how we would reproduce the digest. Why are we trying to reproduce the digest? Like this implies that we're going to compress every layer twice, right? Like is there, instead of doing that, like why are we trying to generate a digest when you're publishing into the daemon? If we need to store it uncompressed on disk, why don't we just store it uncompressed on disk, put it in the daemon, there you have your image, and then, what's the motivation behind recalculating all the digest twice?
It was mainly around like things like cosine that require the digest to be known. So if we could also potentially just move the signet, like the signing flags, to pack publish instead of pack build. So you can sign it only after it's published. So that solves it one way.
I would either do that, or if you're going to compress all the layers initially anyways, you might as well just store them, even if you need even if you want to keep the uncompressed versions around for caching, right? Like if you're going to spend all that CPU on compressing, it could be, in the case of some images, 500 megabytes, right? You might as well
just
put that on disk. Yeah, and so you don't have to deal with trying to reproduce all those bits later, right?
It's just because of waiting on IO and the usage of extra storage that we might not want to do that, but like up for debate, we already store so many things.
Yeah, in fact, I put here two ideas. One of my ideas was just forget about sharing layers and stuff, what we're already doing, and just put the final image on disk. It's going to take more space, but that's it. This is the output. You can use it if you want. and do not mix it with trying to keep and the other one is trying to reuse the cache, re-implement the cache to handle this thing, and then we will have the problem. I believe my idea, I believe the more practical idea is just that, right? Just save the final image that we're going to push to the registering disk, and that's it. You can do whatever you want with it, right?
I
Yeah.
have storage concerns for that though, because some of these final images could be pretty large.
I think if we want to, I'm less convinced that it's important that we store both the uncompressed and the compressed version on disk for performance, because gzip decompression is really relatively fast compared to compression and less CPU intensive. So if we're concerned about storing both the uncompressed and the compressed version in the daemon case, we could probably just store the compressed version and then decompress that on the fly as it's needed. At least that seems much better than the alternative, which is storing just the uncompressed and recompressing it, especially due to the reproducibility thing, given that the reproducibility is guaranteed on the decompression side, and it's like an order of magnitude faster or something like that for gzip. So if that's helpful. I have to drop off a little early, but thanks everybody.
Should we, I think we decided we wanted like a separate set of meetings for all of these discussions anyway. Right? We just schedule those and
Yeah.
Boring people to death with our details. Yeah.
Yep.
Yeah.
I think we should try to figure out how to make this meeting about things that matter more to a wider array of people.
Yep.
And not these very real and important problems, but very boring problems.
Yep.
Well,
I'm very
working
entertained over
sessions.
here. Okay.
It's all you. That's because you're a nerd, Javier.
We have 2 more items on the agenda. Do we want to
I
decide?
think we can't. I think you can't do one because Stephen left, right? Natalie, one and Stephen or something.
The support doc files one? Okay. So I guess we can do the launcher init stuff.
Yep, sure. So that's my item. And so I don't know if everyone here is aware, but like the init system, like PID1 on Linux has some specific responsibilities, mainly about reaping zombies. So processes from processes that are dead that weren't reaped before. This is important because on a Linux system, you have a number of PIDs that are available. If you don't have any PIDs anymore, you can't create new processes. So that means you can't open a shell to restart your machine if the machine is blocked. You can't create new processes in your other like neighbors on Kubernetes, etc. And on Kubernetes, there is multiple ways that this is implemented. So the common case is using the paused container, which runs as PID1 and will reap subprocesses. However, this only works when you have the shared PID namespace between all the containers in a pod, which in some cases is not done for security concerns. And otherwise, basically you need your PID1 process in your container to actually like do it for you. Most applications obviously don't do this because you are not expecting to be run as an init system. And thus, like we are in a case where on some platforms, we need to ensure that we have an init valid program at the start. Otherwise, like our node on Kubernetes might come down. It seems to me, and after a few discussions with some people, that the best place to actually have this PID1 like Reaper would be in the lifecycle launcher, that instead of executing directly the entry point that was defined in the build pack process, we would like install the launcher itself as a PID1 and then fork and exec the entry point itself. And before creating an RFC, I wanted to get a bit room temperature, whether that seems like a valid plan, whether there are any concerns or things that would make this not feasible. It could also be made obviously optional depending on the builder or something like that. Is there any thoughts on that?
I feel like my first reaction is slightly vague hesitation, because we've tried to, we've done this execing rather than fork execing and management on purpose, so that when people, the container looks more like what people expect, right? Like a lot of times if I'm, running my Java process in a container, I'm expect to see that as the init process. And I feel like if we want to do more or different management within init process, is there a reason we wouldn't have a build pack contribute that and sort of put it in front of whatever's going to happen? I guess it's can be difficult with the way build packs can't modify other processes. That's the problem.
Yep, that's exactly it. We discussed a few options. One of it was to make sure that each and every build pack that you have that you want compliant with this introduces in its subsystem that handles this for each process that it creates, or to inject it in the launcher, because there's no way to create an additional build pack that can take previous processes defined by other build packs and modify them with some logic to inject other things. I think the common use case of taking other processes and modifying them has come up a bunch of times in our past conversations. It's just that the interface around that is really ill-defined and weird. What the goal here was actually, regardless of which build pack we were using, we wanted some assurance that this would never happen. The zombie processes being just there forever, nothing cleaning them up. Regardless of the platform, regardless of where it's used, just the container images produced by us should be pristine and follow best practices.
That makes sense. Let me think about this more, because I feel like in general, I'm being loath to take on more responsibilities into the life cycle if there's another way to do it, right?
I think our current plan was to just import the launcher and have a wrapper around it that did the fork and execing for the launcher, install the Reaper, and then let the launcher do its thing and replace that with the default launcher.
Yeah, when you run export, you can configure the launcher, so you can provide a different one if you want to.
Yeah.
I'm not opposed on principle. I just feel like I need to think about it more.
Okay, then I guess I'll open an RFC so that we can have a written trace of all of that.
That makes
Thanks.
sense.
Are you not opposed to the process modification, or are you not opposed to the launcher changes? Which are
I'm more warm on process modification, but I know we've talked about it before and did not come out of that with a slam dunk way to do it. So yeah, I guess I've not totally written off either. I'd prefer a great solution to process modification if we had one, but I'm willing to consider. I need to think more about the init process launcher.
So does that mean we should first write this down in an issue instead of writing a full-fledged RFC, and we can discuss that either there, or would you prefer an RFC for this?
I think just starting with an issue or discussion might help avoid wasting time writing the RFC.
But you
Okay,
get
good.
Yeah, you can always just do a draft RFC that isn't
Yeah.
complete, and we can discuss there and then flush it out into a full one as well. That's an alternative option.
Perfect. Thanks. So I'll do that.
With that, we are at time.